Hello students, today we start the important concept in general organic chemistry, that is the inductive effect. Okay, this is very important for reaction mechanism and all other concept in organic chemistry. Okay, first we have to see the what is meant by inductive effect. Then we have to see the applications of inductive effect. Okay, first inductive effect means the polarity induced in non-polar sigma bond due to adjacent polar bonds. Understand? Due to adjacent polar bond. Okay, is called as an inductive. Okay, means non-polar sigma bond में polarity induce होती है. Polarity induce होती है. Correct है? Okay, due to adjacent polar bond. First polar bond means bond between two different atoms having different electronegativity. This called as a polar bond. And non-polar bond means covalent bond between two same atoms having same electronegativity. These are called as a non-polar covalent bond. Okay. The bond between O2, N2, Cl2, CH3 single bond CH3. Okay. These are the non-polar covalent bond. Okay. Here electronegativity difference of two oxygen atoms set. Oxygen bond, nitrogen bond, chlorine bond, carbon bond. Okay, this bond is a non-polar because this bond formed between two same atoms having same electronegativity. Correct? Okay. In inductive effect, what happens? Polarity induced in a non-polar sigma bonds. Okay, you know that sigma bond and pi bond. Okay, sigma bond is a single covalent bond. Understand? Okay, sigma bond is always single covalent bond. Okay, these are the sigma bond. All these are the sigma bonds. Okay, this sigma bond, and okay, these are the sigma bonds. Correct? Okay. This example CH3, CH2, 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 Cl. Okay. This covalent bond present between carbon and chlorine. This bond is a two different atoms. Carbon chlorine having different electronegativity. Okay, due to difference in electronegativity, bond between carbon chlorine is a polar covalent. Understand that? Okay, polar covalent. Okay, and chlorine is a more electronegative. It withdraws electron from carbon. Okay, it withdraws electron from carbon. Therefore, chlorine acquires which charge? Partial negative charge. And carbon acquires partial positive charge. Okay. Due to withdrawing electron by chlorine atom, this carbon becomes electron deficient. Therefore, this carbon again withdraws electron from next carbon atom. Okay. Therefore, this sigma bond becomes polar. Okay. Initially, this carbon-carbon bond is a non-polar, na? Initially, this carbon-carbon bond is a non-polar. Okay. But this non-polar carbon-carbon sigma bond is present with polar covalent. Understand? Okay, ये उसके adjacent है ना? Carbon chlorine bond polar है. Okay, this carbon chlorine bond is a polar because electron difference between carbon and chlorine is a different. Therefore, this polar covalent bond. Chlorine withdraws electron density, it acquires negative charge. Carbon acquires positive charge. This bond becomes polar. This carbon electron density, therefore this carbon again withdraws electron from next carbon. Therefore, already this carbon-carbon bond is a non-polar. But due to withdrawing electron by carbon, next carbon-carbon sigma bond becomes polar. Okay, this carbon withdraws electron density from next carbon. Therefore, this carbon acquires also partial positive charge delta plus 1. Again, next carbon again withdraws electron density from this carbon. This acquires partial positive charge. Again, this carbon electron division, it again withdraws electron density from next carbon. Therefore, okay, continuous electron transfer takes place from this carbon chain to electronegative chlorine. Correct? Electronegative chlorine. Therefore, polarity induced in a non-polar covalent bond. Okay, this carbon-carbon bond is a non-polar, but polarity induced means partial positive charge is separated in carbon carbon sigma bond due to presence of adjacent polar bond. Correct? These are called as a inductive. Okay, these are called as a inductive. Okay, means polarity induced in a non-polar bond due to presence of adjacent polar bond. These are called as inductive, and this effect is a permanent effect. Okay, these are the permanent effect. Okay, this effect is a permanent. Permanently electron transferred from carbon to electronegative chlorine atoms. This permanent effect and this inductive effect is significant up to 4 carbons. Again, next again carbon is attached to this chain. This inductive effect is not significant. It is significant up to 4 carbons, means up to 4 carbon electron are transferred. Okay, these are the permanent effect. Permanently electrons are transferred. Okay. Again, this inductive effect is classified into two types. Inductive effect is classified into two types. First one, that is the positive inductive effect. Positive inductive effect, these are called as a plus side effect, Pi inductive. In positive inductive effect, and second type, that is the negative inductive effect. These are called as a minus side. Okay, Pi inductive effect and negative inductive effect, that is minus side. Okay, this positive inductive effect and negative inductive effect arises due to the ability of substituent. That means these are the carbon chain. एक कार्बन चेन है ना, एक कार्बन चेन को एक क्लोरीन अटैच है. एक क्लोरीन का नेचर आपको तो पता है, these are the इलेक्ट्रॉन विट्राइल ग्रुप. जो इलेक्ट्रॉन विट्राइल ग्रुप कार्बन चेन को अटैच होता है कि इट शोस माइनस साइड, एंड कार्बन चेन को इलेक्ट्रॉन डोनेटिंग ग्रुप अटैच होता है तो प्लस साइड पे दिखता है. अंडरस्टैंड? For example, if we consider CH3CH2X, it may be anyone. These are the groups. Okay, these are the either electron withdrawing groups or electron donating groups. Okay, these are the either electron withdrawing group, EWC electron withdrawing group, EDC electron donating groups. Okay, कार्बन चेन को अटैच होने वाला ग्रुप इलेक्ट्रॉन विट्राइल नेचर है तो वो माइनस साइड पे दिखा रहा है, इट शोस माइनस साइड. करेक्ट है, इट शोस माइनस साइड. एंड कार्बन को अटैच करने वाला एक ग्रुप है तो इलेक्ट्रॉन डोनेटिंग है तो वो कौन सा पे दिखाता है? प्लस साइड. अंडरस्टैंड? इफ इलेक्ट्रॉन विट्राइल ग्रुप्स आर अटैच्ड टू कार्बन चेन, इट शोस माइनस साइड एंड इलेक्ट्रॉन डोनेटिंग ग्रुप अटैच्ड टू कार्बन चेन, इट शोस plus side. Correct? Okay. Which of these shows plus side effect? Okay, we have to see here. First, positive inductive effect. Okay, positive inductive effect. In positive inductive effect, the atom or group of atom which are electropositive or carry negative charge, it shows plus side effect. Okay, atom or group of atom which carry negative charge, or carry negative charge or more electropositive or more electropositive, it shows plus side. Okay, it shows plus side. Okay, which of these example, that is the O minus, COO minus, then alkyl groups, CH3CH2 ethyl groups, then methyl groups, then methoxide group, all alkoxide group, methoxide group, then ethoxide group. Okay, then metals like sodium, potassium, these are more electrophile, na? It shows which effect? Plus side. Understand? It shows pi inductive. And next one, that is the negative inductive. that is the minus side effect. Okay, correct? Okay, minus side effect. Minus side effect means shows opposite to that of plus side effect. The opposite to that of plus side effect. Okay, we have to take one example of this particular effect. Okay, larger is the alkyl group, okay, greater is the plus side effect. Correct? A tricyclical alkyl groups are, okay, these are the isopropyl group and okay, these are the ethyl groups. Correct? Larger is the alkyl group, greater is the plus side effect. Okay. Minus side effect in which atom or group of atom, okay, which are electronegative or carry positive charge. Okay, are electron neutral groups. Okay, these are the electron neutral groups, and it shows minus side. Okay, which of these? Okay, these are the O R3 plus and R3 plus and H3 plus, then COH group, carboxylic acid group, then nitro group, cyanide group, carboxylic acid group, COH, okay, then all halogens, okay, that is the chlorine, bromine, iodine, correct? Okay, chlorine, bromine, iodine, all of the electron mineral groups, okay, OH groups, etc. Okay, which shows minus side, correct? Okay, then we have to see the applications of this inductive effect. Okay, applications of this inductive effect. Okay, applications of this inductive effect. First application, stability of carbohydrate. Okay, stability of carbohydrate. Okay, you know that carbohydrate means carbohydrate which carry positive charge and which is electron deficient, having 6 electrons in its valence shell. Okay, therefore this carbohydrate formed by which fission? This carbohydrate formed by heterolytic fission. Okay, unsymmetrical breaking of covalent bond between two atoms, it forms the carbohydrate, and this stability of carbohydrate directly proportional to plus effect, that is positive inductive effect, and inversely proportional to the minus effect. Correct? Plus effect and minus effect. Okay. We take one example. CH3 single bond, CH3, then CH3, CH3 plus, CH3, CH2 plus, and CH3 plus. Okay, in this case, okay, first carbohydrate is a carbon carry positive charge. So positive charge carbon atom which is attached to 3 other carbon. Therefore, these are called as a tertiary carbohydrate. Okay, these are called as a secondary carbohydrate. These primary carbohydrate, and these are the methyl carbohydrate. Correct? Okay. This alkyl group is electron donating nature. Positive charge carbon atom, the alkyl groups are attached. Therefore, having more plus effect. Okay. Here these secondary carbohydrate, only 2 alkyl groups, so methyl group attached to positive charge carbon atom, having less plus effect. Here only 1 alkyl group attached to positive charge carbon atom. Here no alkyl group attached to positive charge carbon atom. Therefore, plus effect are present more in which case tertiary carbohydrate. Therefore, this carbohydrate is more stable than secondary carbohydrate, than primary carbohydrate, than the methyl carbohydrate. Correct? Okay, then next application of this, okay, we have to see stability of carbonate. Okay, stability of carbonate. Correct है? Okay, stability of carbonate inversely proportional to the plus side. Inversely proportional to plus side and directly proportional to the minus side. Correct? If we take one example of this, again here CH3 CH2 plus and NO2 CH2 CH2 plus. Okay, in these two cases, okay, which component is more stable? Both are primary components. This alkyl group electron donating nature, it shows plus effect. In this case, alkyl group nitro group is attached. This nitro group shows which effect? Minus effect. Stability of carbonate inversely proportional to minus effect. Therefore, minus effect decreases the stability of carbonate. In this case, which one is the more stable? Okay, this CH3 CH2 plus is the more stable. Okay. Again, stability of carbonate stability of carbonate directly proportional to minus effect and inversely proportional to the plus effect. Correct? If we take one example of this, okay, CH3 okay, CH2 minus, okay, CH3 CH2 and O2 and CH3 CH2 minus CH2 okay, NO and CH2 minus CH2 Cl. Okay, in this carbonyl, okay, first carbonyl means carbon carries negative charge, okay, and having electronic outlet is a complete. Okay, this alkyl group attached to carbonyl, it shows plus effect. Here nitro group is attached to carbonyl, it shows minus effect. Here cyanide group is also attached to carbonyl, it shows minus effect. Therefore, stability of carbonyl directly equal minus effect, inversely proportional to plus effect. If you consider this first case, this second case, and this third case. Okay, this having less stability. In between second and third case, nitro group having more minus effect. Therefore, which one is the most stable? Second, okay, then third, and then which come first. Understand? Okay, this is the stability of carbonyl. Right? Again, one example we take here. Here CH2 minus CH2 OH CH2 minus CH2 NH2 and CH2 minus CH2 here. In these three cases, okay, OH group is attached to carbonyl, NH2 group is attached to carbonyl, and chlorine is attached to carbonyl. In this case, chlorine is a more electronegative. Okay, chlorine more electronegative, having more minus effect. Therefore, okay, this carbonyl is a more stable. Right? This carbonyl is a more stable. Okay. Therefore, this stability of carbonyl we have to define by using inductive effect. Understand that? Okay. Next application is acidic and basic shell. Okay. These applications we have to see the next lecture. Okay. Stop it.